Good night, students. My name is Umesh Prasad. This video is based on tomorrow's topic, that is stationary points, or which is also known as turning points. This video is very simple. It is very simple and straightforward. So let us begin. Given the function y is equal to x cubed upon 3 minus x squared upon 2 minus 2x plus 5. The stationary points are given by dy dx equals to 0. Now, using the first derivative, y is equal to x cubed upon 3 minus x squared upon 2 minus 2x plus 5. When now we derive this expression using the first derivative, dy dx is equal to 3x squared upon 3 minus 2x upon 2 minus 2, leaving us with dy dx is equal to x squared minus x minus 2. Using this newly formed expression, which is dy dx, we do the second derivative of this expression. And the second derivative of this expression would be equal to d squared y upon dx squared is equal to 2x minus 1. When you're finished doing that part, the stationary points dy dx is equal to 0. Now, we have already found dy dx as x squared minus x minus 2, because it's saying here dy dx is equal to 0. So we already find dy dx, and dy dx is equal to x squared minus x minus 2, and we equate it to 0. Now this here forms a quadratic expression. Now when solving a quadratic expression, we could solve it by using two methods, and that is the quadratic formula and factorization method. Now, just by looking at this, we know that we could use the factorization method to get an answer, and the answer is x minus 2 and x plus 1. This also is equal to 0. Now, the other step is taking those 2 points when x is equal to 2 and x is equal to minus 1. We substitute x is equal to 2 and x is equal to minus 1 in the second derivative, which is d squared y upon dx squared, and we will get d squared y and dx squared is equal, when x is equal to 2, we will just replace the 2 with the x here. So 2 times 2 multiplied by 2 is equal to 4, and 4 minus 1 is equal to 3. This here, we do the same. 2 times minus 1 will give you minus 2. Minus 1 is equal to minus 3. Therefore, we can say x is equal to 2 and gives y a minimum value. And when x is equal to minus 1, it gives y a maximum value. In this case, the next step is to substitute the turning points, which is x is equal to 2 and x is equal to minus 1 in the original expression. The original expression is y is equal to x cubed upon 3 minus x squared upon 2 minus 2x plus 5. Now why we substitute the x values in the y values? If you have noticed that we have found x values already, the only values that are missing are the y values. So we substitute the x values into the original expression, finding for y. Upon doing that, we'll have y is equal to, where we see x, we replace it with 2. Y is equal to 2 to the third upon 3 minus 2 to the second power upon 2 minus 2 times 2 plus 5. When we work this expression out, we'll have y is equal to 1 upon 2/3. And we do the same. We plug in x is equal to minus 1. When we work this expression out, we'll have y is equal to 6 upon 1/6. So what are the things that we know? We know that at x is equal to minus 1 when y maximum is equal to 6 and 1/6. We also know that at x is equal to 2, y minimum is equal to 1 and 2/3. Here is a graph to show you what the curve will look like. Now, first of all, you drop your coordinates, your x-axis, your y-axis, put in the necessary information, and where y is the maximum, that is 6 upon 1/6, we assume a point, the highest point on the y-axis, which is probably here, 6 and 1/6, which is the maximum value, and the lowest, which is 1 and 2/3, which is the minimum value. Now, when drawing the minimum curve, we draw down before the minimum curve. In fact, we draw up before the minimum curve and after the minimum curve. When drawing down for the maximum curve, we draw down before the maximum curve and draw down after the maximum curve. Now when you find these 2 points here, when you finish finding these 2 points, you join the lines, or you join the points together. This should have been a curve instead of a straight line here, but this is just a rough sketch to show you what the graph would look like using the maximum and minimum points. Now, how do we find the intercept here? How do we find reflection here? Inflection here? We know that the original function is equal to y is equal to x cubed upon 3 minus x squared upon 2 minus 2x plus 5. So how do we find the y inflection? If we look at the graph here, we'll see that at x it is equal to 0. And how do we find the y? Simply, part of the answer is here already. We substitute the 0 into the original function. And upon substituting 0 in the original function, this will go to 0, this will go to 0, and this also will go to 0, leaving us with positive 5. So hence y is equal to 5. So you replace that now onto the graph, indicating it onto the graph. And I'd like to thank you very much for listening and watching. Have a great night.